All right, we got a 36-degree ramp. Box is sliding down it, and Mr. Korsmito wants to slow it down. So it's going this way down the ramp, and just based on the wording of the question, it probably makes sense that the applied force is going to be opposite that, because he's trying to slow it down so it doesn't crash at too much of a speed at the bottom there. Which way is the friction? Well, the friction is going to be resisting the velocity as well. So we actually got two forces working in that direction. And they are slowing it down, and they're also combating the gravity. Okay, so let's set up directions, define directions, and get started. So X direction, well, I'll make it down the ramp, and I'll make Y direction same direction as normal force. Okay, a free body diagram. Starting with gravity. It's just the simplest, I find, starting with gravity, because it's always pointing directly down when we're dealing with any objects on the Earth. I'll draw in the components to that. And the normal force perpendicular to the ramp is going to balance out the y component of gravity. And we don't want this box flying off the ramp or digging a hole into the ramp or anything like that. So I'll use the tick mark here to show that they are equal in magnitude. Okay, and then the other two forces I talked about in the above diagram, so applied force and frictional force, both of them pointing up the ramp or in the negative x direction. And the box is slowing down. The box is slowing down, so the forces are not balanced. There is an acceleration there. Okay, so equation-wise, in the y direction, we will have the normal force being equal in magnitude to the y component of gravity. I'm going to go ahead and rewrite the y component of gravity as mg cos theta. Okay, now in the x direction, things get a little interesting. This is supposed to accelerate. It's supposed to slow down. So in that case, forces are not balanced, and I'm going to write Newton's second law. Well, I'll write that the net force, the magnitude of the net force, is going to be the sum of the applied force and the frictional force. Well, okay, I'm changing my mind. Okay, I'm going to change my mind. Instead of using magnitudes, maybe I'll use pure vector notation here. So the net force is the sum of all the vectors. I'm working with the x direction here. So it is the sum. Sum means add, so applied force plus the frictional force plus the x component of gravity, which is FGX, which is in the x direction. So FGX by itself is just a magnitude. Got to add the direction to it. It's pointing down the ramp, so it's in the positive x direction. Yeah, okay, I'll use the vector format for this. I will rewrite the net force as ma, Newton's second law. The applied force, I'm supposed to solve for that, so I'll just leave it as FA. It says find find the applied force. The friction, I'll rewrite it as the formula is mu times the magnitude of the normal. Now I can't just leave it like that because in that format there's no direction to it. So I better add the direction in there. So is friction going in the x direction or the negative x direction? It looks like it's going in up the ramp, but I defined down the ramp as positive, so I think I do have to change this plus to a minus, because it's going in the negative x direction. Meanwhile, the x component of gravity, which is mg sine theta, that is pointing down the ramp, so that is in the positive x direction. All right, so I suppose I'll isolate this for applied force now. So applied force will be, I gotta move everything over. So there's MA on the other side to begin with, but now I'm gonna say plus mu times normal, because I've got to add it to get it to the other side. And then subtract mg sine theta. Okay. And I'm going to make a substitution. It's getting pretty complicated here. But that expression for normal force, mg cos theta, I'm going to substitute that into equation 2 right here. Okay, that'll make this expression even bigger. So we'll get MA plus mu mg cos theta in the x direction minus mg sine theta x direction. Okay, so I'm just about ready to fill in the numbers. Just let me do a quick scan here. MA, do I know the mass and acceleration? Yeah, I know the mass is 18 kilograms. And I know the acceleration is a slowdown of 1.2 meters per second squared. Which is the acceleration in the positive x direction or is it in the negative x direction? Well, the box is supposed to be getting slowed down, so the acceleration should be in the opposite direction that it's moving. So it's actually in the negative x direction. So should add a negative there. Okay, so acceleration is negative 1.2 meters per second squared x hat. Do I know my mu? So keeping going on the equation. Yes, they tell us the coefficient of friction is 0.16. Do I know the angle? Yes, it's 36 degrees. And the G value is 9.8. So I'm golden. Got everything I need here. So I'll sub it in. I guess I could common factor the mass, so I don't have to type it in 3 times in the calculator. Okay, so I'll write the numbers in. And now I will throw it in the calculator. Okay, so I'm getting an answer of negative 102 newtons. So a negative answer is good because this is slowing down. So it's opposing the direction of the velocity. Sig figs wise, it should be 2, so I'll just rewrite it in scientific notation here. Oh, newtons, got to get the newtons in there. All right, there we go. That was a longer one.